matrix and determinant together 12 to 15. Yes. So let us start consistency and inconsistency of system of equations. Let me revise that part once, which is Martin's rule, which we have done before, that solving system of equations by matrix method for a11x, a12y, a13z equal to say d1, a21x, a22y, a23z equal to d2, a32y, a33z equal to d3. What we did here in Martin's rule, we have taken A equal to this matrix, you remember it, A11, A12, A13, A22, A31, 32, 33, x equal to xyz, and B equal to the right hand side, the augmented matrix, which we have referred as the augmented matrix. This is coefficient matrix, this is the variable matrix, and this is the augmented matrix, the right hand side matrix. And what we did before, we have written the given system of equations in the form Ax equal to B, isn't it? Given system can be written as Ax equal to B. Now we multiply both sides by A inverse. Then what do you get? If you multiply by A inverse, then X going to be equal to A inverse into B. Okay? This A inverse, you know, given by adjoint A by det A. This is true for a system of equations containing two variables as well as system of equation containing three or more variables. So one essential condition for solving this system of equations is that det A either equal to 0 or not equal to 0. So based on this, we consider two cases over there. Case 1, where we are taking det A not equal to 0. Let det A not equal to 0. What does this imply? This implies that the given system of equations have unique solution. Unique solution means you will never get two values of x, y, z. You will just get one value of x, y, z. Never two values of x, y, z. Okay? The given system of equations have unique solution if det A not equal to 0. Okay? We'll get only one value of x, y, and z, and we will say that the system of equations in this case, the given system of equations are said to be consistent. So consistency implies what? Consistency implies existence of solution. Consistent means we can get the values of x, y, z. And with the examples in the previous session, we have learned how to get x, y, z. All of you remember that? But today's aim is not to repeat that. We'll be discussing the case when data equal to 0 also. What to do? Case 2. When data equal to 0. Let data equal to 0. Question arises, will you get solution of system of equations in this case if data equal to 0? Yes or no? Data equal to 0 means what? Adjoint A by data going to be indefinite, isn't it? Something by 0 form. So apparently it seems that no, it is not possible. But there is a case, there is a sub-case here. What sub-case will be there? Let data equal to 0, then we will be considering two different cases here. In this case, we will be considering adjoint A into B. We will be finding adjoint A into B in this case. Okay, when data equal to 0, find adjoint A into B. Okay, if adjoint A into B equal to 0 and if adjoint A into B not equal to 0. Based on this, we will say whether it had solution or not. If this thing 0 in addition to data 0, then the given system of equations has infinitely many solutions. I'll show you how infinitely many solutions can exist here. Okay, how to get. And again, in this case, the given system of equations are consistent. This implies that given system of equations are consistent. Am I clear? We will be checking adjoint A into B. If adjoint A into B equal to 0, in addition to data equal to 0, this is satisfied. Under that, if this is also 0, then given system of equations has infinitely many solutions, and we say that system of equations are consistent. No, consistent. Solution exists means consistent. Solution doesn't exist in this case. So this implies that, I'm coming back to that point, trivial non-triviality. In this case, solution does not exist. It means given system of equations are inconsistent. No solution exists, we'll say it is inconsistent. So consistency implies what? Solution exists. Inconsistency means solution doesn't exist. Now another term is used often in this solution of system of equations, trivial and non-trivial solution. Trivial solution means x, y, z, 0. Trivial solution implies that x, y, z all three are equal to 0. Non-trivial solution means this implies that at least one of them is non-zero. Clear? You understand? At least one of them non-zero, then we'll say that it is non-trivial. So just clarify one thing. In this case, system of equations have trivial solution or non-trivial solution. When infinitely many solutions are there, trivial will be only one solution, x0, y0, z0. So at least one non-zero solution is there. So in this case, you can easily say that it has system of equations has non-trivial solution. Clear? Let us work on it first. Okay, this is a very powerful method. Cramer's rule one alternative for this, but Cramer's rule not included in CBSE syllabus. This is included in CBSE and equally applicable for entrance exam, this concept. So when data is 0, don't leave the sum that it has no solution. It has if adjoint A into B also 0. Okay, let me take one textbook problem to decide whether it is consistent or inconsistent. This I am taking as 3x minus y minus 2z equal to 2y minus z equal to minus 1 and 3x minus 5y equal to 3. This is consistent or inconsistent, we have to decide. I have written this manner because no x is there. I have written this manner because 0 into z is there. Okay? So what you have to do there? You take A. Here A equal to what? This coefficient matrix 3 minus 1 minus 2 0. This is 2 minus 1 3 minus 5 0. A equal to this. Okay, so let us find adjoint A first. And what is B? Let me write. B is this matrix, that is called augmented matrix. Okay, this is coefficient matrix, this is augmented matrix. We will find adjoint A. Hope you remember. Here adjoint A is transpose of the cofactor matrix. So transpose of the cofactor matrix, it is 2 minus 1 minus 5 0 minus this row and column of 3 0, then this one row and column of 0 2 3 minus 5. Now for this one minus 1 minus 2 and then plus. For this one there will be 3 minus 2 3 0 and for this one minus of what? This is 3 minus 1 3 minus 5 and for this minus 1 minus 2 minus 2, 2 minus 1, and for this one again negative. Remember it, this row and column of 3 minus 2, 0 minus 1, and then for the last one you write the cofactor. This is 3 minus 1, 0, 2. Clear? This is nothing but the plus minus plus minus plus minus plus minus plus. So it is transpose of minus 5, 3, minus 6, minus 10, 6, minus 15 plus 3, 12. I'll check once again. 1 plus 4, this is 5, this is 3, and this is 6. Once more, quick revision. 0 minus 5, because minus 1 is plus, it is minus sign. Minus 3, before that minus, so it is plus. Minus 6, this one 10, so minus 10, and this part minus minus plus, this one minus 15 plus 3, minus 12 plus 12, and this one 1 plus 4, 5, this one minus 3 plus 0 plus 3, and this one 6. Clear? Now transpose of this minus 5, minus 10, 5, 3, 6, 3. This one done. I have taken the transpose. Clear? So this is adjoint A. Now what we are going to check? We are going to check it with adjoint A into B. I have done it already. This is minus 3. So minus minus plus. 0 plus 3 is 3. Oh, this will be minus. Right. Correct. This is correct, I think. So it is minus 5, minus 10, and minus 3. It will be. Now find adjoint A into B. Let us find adjoint A into B. Check whether you are getting a zero matrix or not. Minus 10, 5. This multiplied by, you better check it yourself. Do the multiplication, check whether you are getting zero matrix or not. Minus 10 plus 10.
0 minus minus 10 ওখানে প্লাস 10 আসছে আর বাইরে একটা মাইনাস আছে প্লাস 10
This one?
হ্যাঁ দেখো
0
minus plus 10
minus 10.
so that is minus 10 আর বাইরে
This will be plus 10. Right. Mine is wrong. Now do it. Check. Minus 10, minus 10. Is it coming zero matrix? Check. If it is zero matrix, then can be solved. Am I getting zero matrix? Minus 10 plus 10. No, minus 10 minus 10. Minus 20 plus 15. So minus 5. Isn't it? And this one minus 6. Minus 6 plus 9. And this one minus 12 minus 24 minus 6. So this is not equal to 0 matrix. Big 0 means 0 matrix. So what will be your comment? Is data equal to 0? That we haven't checked. Adjoint A into B not equal to 0. Data, let us check. Data is 3 into, please check my calculation, 0 minus 5 plus 1 into 0 plus 3 minus 2 into 0 minus 6. So minus 15 plus 3 plus 12. This is 0. But adjoint A into B not equal to 0. So system of equations are inconsistent. Am I clear? Solution doesn't exist. You can say proudly, I have done it. Okay. Let us check another one. Find the consistency and inconsistency of, I am taking a 2 by 2 matrix. Say x plus 3y equal to 5. After this I will show you one where there is infinitely many solutions. This you can start before I do it here. Just check whether infinitely many solutions exist or not. You find data, normal method. Then adjoint A into B, you know how to find the adjoint A. Find it first. Do it first. Adjoint A is not inverse, just adjoint. Change the side here and change the signs here. Clear? Now B matrix is what? That augmented one is 5, 8. So adjoint A into B. Adjoint A is what? Minus 2, 1 into 5, 8. So let us check what happens there. Multiply these two. Adjoint A you have understood. So 30 minus 24, 6 and minus 10 plus 8 minus 2.
For adjoint A, are you taking the rows first or the columns?
I have to take the transpose. Wait a minute. Have I taken the transpose? Yes, everything is done. That you interchange these two and change the signs of these two. Finished. This I have repeated. Determinant equal to 0 and this is not equal to 0. So system of equations inconsistent. But I have to show you in one case it is consistent. Solve the sum I am giving you here. 3x plus 4y equal to 7 and 6x plus 8y equal to 14. Do decide. Before I do it, you must complete. Check whether it is consistent or inconsistent. If inconsistent, find the solution with my help. I will help you definitely. Hope you all are doing it with me. So here B matrix is 7 4 7 14. So adjoint A into B you calculate minus 6 3 multiplied by 7 comma 14, isn't it? So these two if I multiply, so adjoint A into B coming means zero matrix. So infinitely many solution. This is the ideal case of infinitely many solutions, isn't it? But how to solve it? How to get infinitely many solutions here? Here we will follow 3 steps. Here 2 steps will be enough because 2 cross 2 order matrix. So I am telling you the process how to finish the sum. Now to find the solution, let y equal to k. Then 3x is what? So x is 7 minus 4k divided by 3. So what will be the answer, final answer? Required solution, you will write x 7 minus 4k by 3 and y equal to k, where k belongs to R. Am I correct? Hope you have understood. Let us take another textbook sum. It's clear? Number 3, in this context, you take 5x minus y 4z equal to 5, 2x plus 3y 5z equal to 2 and 5x minus 2y plus 6z equal to minus 1. This we have to check whether solution exists or not, then we have to solve. You write A matrix first. Do it before I complete here. This is 2, 3, 5. 5 minus 2, 6. X, Y, Z and B equal to 5, 2 minus 1. Isn't it? B is 5, 2 minus 1. So find adjoint A. You know how to find? You write adjoint A by writing in the form of that inside matrix, write those small determinants and decide. We can do mentally also this step. 18 plus 10, 28. Then this one, minus of 12 minus 25, 13. And then this one, minus 4 minus 15 minus 19. Then for this one, minus 6 plus 8, 2 minus 2. Then this one, 30 minus 20, 10, minus 10 plus 5, minus 5, it will be plus 5. Then for this one, minus 5 minus 12, minus 17. For this one, 25 minus 8, it will be minus 17. And for this one, plus 17. Am I correct? It's alright, check calculation once. Now find adjoint A into B and check B is there. B matrix is there. So find adjoint A into B. Adjoint A into B going to be 28, 13, 10, 5. Clear? Multiply this by adjoint B. I mean 5, 2 minus 1. So this is 140. No, it is not coming 0 matrix. Check once. Check, check, check. Five, 2 minus 1. Is it coming 0? Tell.
স্যার আমি মানে ট্রান্সপোজ নিয়েছি ওই কোফ্যাক্টর ম্যাট্রিক্সটা না তো
Huh?
ট্রান্সপোজ তো নেননি
Transpose not taken.
নো স্যার
So let us take transpose. Adjoint A will be transpose of this. You will definitely take adjoint A will be transpose of this thing. We have just we have written the cofactor matrix. Transpose was not taken. So take the transpose and decide. This is 28 minus 2 minus 17, 13, 10 minus 17, minus 19, 5, 17. This multiplied by adjoint A into B also you calculate. This into B, 5, 2 minus 1. So 140, is it coming 0? Check.
No.
So this is inconsistent. Clear?
Done, sir.
So in your board exam, this session made for board exam, no? Consistency, inconsistency. That part only we are supposed to do. I am not discussing any competitive exam question here. But this you need to decide. And you need to know how infinitely many solutions can be found out. Okay? Now, there may be a special case where the right hand side is 0 permanently. I mean, 0 permanently means it is homogeneous system of equations. What to do for homogeneous system of equations? Know by matrix method first. For homogeneous system of equations. Homogeneous system of equations like this. I am just writing a1x plus b1y c1z equal to 0, b2y and how to decide whether this system of equation has infinitely many solutions or finite number of solutions. This is a very important concept for JEE also, for homogeneous system of equation, because in this case whatever adjoint A is there, adjoint A into B is what? Permanently 0. Why? Whatever adjoint A is there, this B is 0 matrix. This result permanently 0. So for consistency or inconsistency, I need not check adjoint A into B. What I need to check, whether data equal to 0 or not. If data equal to 0, then what will happen? Data, first you consider data not equal to 0. Data not equal to 0 implies what? Case 1, this will treat differently. Case 1, if data not equal to 0, then x, y, z all are equal to 0. This is the case of trivial solution. Okay? If data not equal to 0, go by matrix method. The right hand side 0 only. You will get trivial solution only. x0, y0, z0. Why? Because when you multiply x equal to, I am just telling you, there is no confusion here. X is A inverse into B. Permanently you are getting a 0 matrix over there, isn't it? And this side x, y, z. So what do you get? x0, y0, z0. But if delta equal to 0, then what will happen? Do I need to check adjoint A into B? No, because it is permanently equal to 0. So in this case we will say that system of equations have infinitely many solutions. Case 2, let us note it down. Case 2. If data equal to 0, then the given system of equations have infinitely many solutions. Is that clear? So this is one advantageous position. For system of equations which is homogeneous system of equations, if right hand side is 0, then this will be right hand side is 0, then it will have either trivial solution, all three are equal to 0, or infinitely many solutions. I am giving you two problems here. Solve it. Decide whether the given system of equations have unique solution, I mean trivial or non-trivial solution. So write x minus 2y plus z equal to 0, 2x plus y plus 3z equal to 0, and x plus 3y plus 2z equal to 0. Let us solve it step by step. Actually, if it has two variables only, that case you have done in class 10, isn't it? Two lines may be coincident or parallel. Or parallel means?
No solution.
Understand what I am saying? If parallel, I mean x plus 2y equal to 5 and x plus 2y equal to 7. They are definitely parallel. So in that case, no solution exists. For 3 cross 3 ordered, you have to check that. Data you find first, data you check. Data you must check. For this sum, data is 1 minus 2, 1, 2, 1, 3, 1, 3, 2. This is nothing but 2 minus 9 plus 2 into 4 minus 3 plus 1 into 6 minus 1. Isn't it? So this is minus 7 plus 2 plus 5. I am getting 0. I am getting 0. So what will be conclusion? The given system of equations have infinitely many solutions. Isn't it? That in the previous session I told you that only, no? That if data equal to 0, then it will have infinitely many solutions. So how to get the solution here? For solution, how to get? Let z equal to k. Okay? Take z equal to k. Now rewrite first two equations or second and third as you like. So x minus 2y plus k equal to 0, number 1, and 2x plus y. This is the method to get the solution. So what we will do here? 1 into 3 minus 2 we will do. So 3x, 3k equal to 0, and this is 2x plus y plus 3k equal to 0. Okay? So just subtract. Okay, wait a minute. This, if you multiply by 3, then it won't be possible. You multiply by 2, isn't it? Because x we have to eliminate. So 2x, right? 2x minus 4y plus 2k equal to 0. Then subtract. Two x minus 4y plus 2k. Clear? Now subtract. So these two are getting cancelled. This is coming minus 5y. So y equal to minus k by 5. X will be what? 2y minus k. Minus 7k by 5. So solution will be what? Required solution is minus 7k by 5 minus k by 5 and what you have taken? Z equal to k. Z equal to k also you have to take Z equal to k. Clear? This is the required solution where k belongs to R. Hope you have understood. Okay? And this you never forget. You don't need to use Kramer's rule if you remember this. Got the point? Kramer's rule, some students always like. Okay, for their entrance exam. First, Kramer's rule not in CBSE board exam. So, if matrix method fulfills all the condition what you are expecting there regarding those equations, then go by matrix method. So, this is the last class on matrix, Martin's rule. I have a problem to discuss with you which is very important, which is not given in the textbook. Okay? This I am going to discuss you. Before I leave it, we must solve it together. Let the matrix A, this is very, very important. 1 and concept is required everywhere. 1, 4, 1, 1 minus 3, 2 and B equal to 11 minus 5 minus 14 minus 1 minus 1 2 minus 7 1 6. Okay, find AB. Question is this, continuing, find A into B, use it to solve x minus, your board has asked this question before, not in recent years, they have asked this. Use it to solve these equations. X plus 4y and this is plus 2z equal to 1. Clear? There is no Martin's rule here, or it's there. Sometimes we get good with Martin's rule, no? Writing cofactor of one element, one to element, the way given in your book. Most of you will follow that method only. Even I have told you this easiest method here. Okay? So this is one alternative method, which is actually restatement of Martin's rule. Find AB. Just check what AB coming. Check once. And this will help you to get the inverse directly. Just check A into B. A into B is 1 minus 2 3 1 4 1, this multiplied by 11 minus 5 minus 14 just check check the product, what it's coming. -1, 2, -7, 1, 6. Just multiply. Eleven plus 2, 13 minus 21, it's coming -8. This one -5 plus 5, 0, -14, and this is also 0. 0, -8, 0, 0, 0, -8. Check. I got this thing. A into B I found. You all agree? So what is the advantage of this method? You got A into B, how much you got? Here A into B you got -8, you take common I, isn't it? A into B -8 into I. What you need to find solution? X equal to A inverse into B. Can't I say that B by -8 equal to A inverse into I? So A inverse, what is its value? -1/8 into B. We got inverse. We don't have to find by that method. So A inverse, what have you got? -1/8 into B matrix. This is alternative method to get -14, -1, -1, 2, -7, 1, 6. Do you understand? It's all right? Everyone understand? Now what? You got A inverse. How to solve it? So put X equal to that A inverse. 11 -5 -14 -1 -1 2 -7 1 6 into B. B is what? The augmented matrix. This is not B matrix here. For solving we will take this matrix only, no? Not this B. Augmented one. Clear? Now multiply and solve. So X, Y, Z going to be what? -1/8, 66, -60, -8, and -6, -12, -18. Check once. It's coming -6, -12, -18, -16. Good. Very good. -42 plus 12, -30 plus 6, -24. Thank God. We got solution so easily, and this is alternative method. If you go by Martin's rule in this case, you won't get marks. This came in your board paper. Okay? This is end of session on matrices for boards. Later on division session will be there. This much you need maximum. Okay? consistency, inconsistency wasn't very important topic for board, but I'm guessing question may come this year. Why? Because syllabus is first reduced and inside the book has become very thin, the topic included. So you must try to understand it properly. Clear? See you again.